All right, so talking about Vieta's formula today, which appears quite a bit, especially on DMI questions. So Vieta's formula is actually something you can use for all types of polynomials, but we primarily focus on quadratics and cubics. Depending on how quadratics go, I will determine whether or not we'll go through the cubics. So basically, Vieta came up with a way of figuring out the sum and product of the roots of a quadratic using the parts of the quadratic equation in standard form, which is, as always, ax squared plus bx plus c. And what you want to remember is that the roots are the solutions for x. And we have a very nice formula for that, especially when they're not factorable, and that's the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac. And all of this is divided by 2a. So if you think about this, the solutions are embedded in here. There's two solutions for quadratics normally, unless the discriminant goes to 0. And if it doesn't go to 0, then the two are basically determined by this guy here, because one is plus and one is minus. So the easy one that you can always derive really quickly is the sum of the roots. So if this is the two solutions, negative b plus square root of b squared minus 4ac over 2a, and then negative b minus square root of b squared minus 4ac over 2a, if we're adding them, that means we're just adding those two components of the quadratic formula. So root 1 is going to be negative b plus or minus the square root of b squared minus 4ac. And all of this gets divided by 2a. Actually, I'm sorry, it's not plus minus, it's just plus. And then what we're going to do is we're going to add it, since we're finding the sum of the roots. All this is divided by 2a. Now this is very easily simplified, because what you're doing is you're adding with a common denominator already. The denominator is 2a, so I don't need to modify anything in the numerators. And you can already see that if we do this, this term and this term will cancel out. And so the sum of the roots ends up being negative 2b divided by 2a. And that simplifies to negative b over a. And this is the sum of our roots. So that's a nice quick way to find the sum of our roots. The product of the roots is also not difficult. It's just that it does take some recognition of what's going on. And rather than rewriting all of this, I'm just going to and then what we're going to do here is we're going to multiply our roots together. Now, where it is important that you recognize what's going on here, I'm going to rewrite this whole thing as just one long fraction. And in one term, it's negative b plus the square root of b squared minus 4ac times negative b minus the square root of b squared minus 4ac. And all of this gets divided by 2a times 2a. So the question then is, how do we actually simplify the numerator? But if you remember back in Algebra 1, you learned the difference of two squares, x plus a times x minus a will get you x squared minus a squared. And we're going to use that same concept to simplify this, because look, we do have the same two terms, and the only thing that's different is the plus and the minus here, right? So what we're going to end up doing is we're going to do negative b squared minus the square root of b squared minus 4ac squared all over 4a squared. Now this ends up being very nice because that square on the second part of the numerator will cancel out the square root. Negative b squared ends up being b squared minus b squared minus 4ac. That's still grouped together, all divided by 4a squared. And then we distribute that minus sign. So it's b squared minus b squared plus 4ac. All of this gets divided by 4a squared. And what ends up happening here is that this obviously is going to cancel. And you're going to get 4ac divided by 4a squared, or 4 times a times a. And then all we have to do is cancel out 4a. And you get c over a. And so the product of our roots of a quadratic can just be found by doing c divided by a. I am going to go over one DMI question really quick. I'm going to have to remember it from memory, so forgive me if it's not verbatim the same exact question, but the structure of it is the same. So we have the function f of x is equal to 4x squared plus 5x plus c. And the question tells you the function has two distinct roots of sine of t and cosine of t. So they're introducing some trig into this. And they're asking, what is the value of c? So, a is 4, b is 5, c is c, because we don't know that. And what we're going to do here is we're going to use Vieta's formula to kind of piece all of this together. So, if we think about it, we already know that negative b over a is going to be the sum. And then we also know that c over a is the product. We know the roots, sine of t and cosine of t. That's the roots, right? So this is equal to the sum of the roots, and this is equal to the product of the roots. Now, if we use our actual values here, b is 5, so the sum, so sine of t plus cosine of t is going to be equal to negative 5 over 4. We're also told that the product of them is c over a. So sine of t times cosine of t is equal to c over 4. So it's a puzzle. The actual math behind this question is not hard. So the first thing we can do here is we're solving for c, so I would multiply both sides of that second equation by 4, and you get 4 sine t times cosine t is equal to c. So the question is, how do we now piece all this together? So the one thing that should ring a bell is kind of like Pythagorean identities with sine and cosine. So if I take the top equation and I square both sides, I'm going to get sine squared t plus 2 sine t cosine t plus sine cosine squared t. Now you look over here, this looks really similar to this, except it's half of it, right? Because we're multiplying it by 2 instead of multiplying it by 4. So that means that this guy is just equal to half of 4 sine t cosine t. But that's equal to c, so this guy's actually just equal to c over 2, right? Now, all of this, I didn't leave myself much room here. I'm going to erase this. Remember, we squared that side, and I actually forgot to write this down. I got to square the other side, and that's going to be 25 over 16. So this is now going to be sine squared t plus cosine squared t plus c over 2 is equal to 25 over 16. And remember, we're solving for c, but your Pythagorean identity is right here. Cosine squared theta plus cosine squared theta is always equal to 1. So now this becomes 1 plus c over 2 equal to 25 over 16. I subtracted 1 from both sides, and I get 9 over 16 is equal to c over 2. And then I multiply by 2 on both sides, and I get the value of c is 18 over 16. DMI and all math team competitions will not give you credit if you don't simplify. So this is equal to 9 over 8. And that's the answer for this one.